Hey guys, welcome to our YouTube channel. We are super excited to have you in our space. So today we want to look at a problem that came in a contest in Spain, the Primera Contest, and also appeared in the Canadian Mathematical Society. It's a very interesting question on polynomials, and we actually hope that you stick around to enjoy the content. And if you actually enjoy it, make sure you like the video, subscribe, and turn on the notification bell so that you don't miss much more interesting content coming up in our channel. All right, thank you so much. Let's dive right in. All right, guys, so the question goes, find out the values of a such that the zeros of the polynomial f of x equals to x squared minus ax plus 2a are integers. All right, the very first thing you want to notice with the problem is that f of x is actually not just any other polynomial, but it's actually a polynomial of degree 2, which in that case makes it quadratic, right? So we can actually solve this equation fundamentally by factorization. So if the two factors of the polynomial or the roots of the polynomial be x1 and x2, then we can actually write something like f of x actually being equals to x minus x1 into x minus x2. That's factorizing the polynomial, right? So we can go ahead and say that, all right, so if you expand this and simplify and equate corresponding coefficients, you'll notice that sum of roots, which is x1 plus x2, would just basically be a, and our product of roots would actually be 2a, right? So another way you can think about that is just sum of roots equals negative b over a. And so if the quadratic equation is actually ax squared plus bx plus c, right? And then our product of roots would actually just be c over a, and where our c is just 2a and our a is 1. All right, so we can go on and then say that if this product of root is actually 2a, but what is our a? Our a is actually x1 plus x2, right? The sum of the roots. So we basically have that x1 into x2, product of the roots is 2 times sum of the roots, right? So if we simplify, we can bring these terms the other way, expand and bring the terms to one side. So you'll notice that we actually have all of that now, right hand side just being 0. And now we can actually rewrite this such that we actually add 4 on both sides and then we factorize. So if you add 4 on both sides and then you factorize, notice you are going to have x1 into or x1 minus 2 into x2 minus 2, which gives us 4, right? So now you have a product of two stuff giving you 4. There are only 4 ways of writing 4 as a product of integers. So what are those ways? You can actually have 1 times 4, right? Positive 1 times positive 4, it gives you 4. Or you have negative 1 into negative 4, it gives you 4. Or you have positive 2 and positive 2, which gives you 4. Or you have negative 2 and negative 2, which again gives you 4. So these are like the 4 different ways you can actually multiply out integers so that you actually have the result to be 4. So we're just going to go over here and then do some really good stuff, right? So you notice that this is a product of the first root minus 2 and the second root minus 2, right? So now we're saying that this product can actually be in this form. So notice that we are taking plus 1 and plus 4 as the first ordered pair of this product, right? So if we say plus 1 and plus 4 first, so we can actually say x1 minus 2 to be 1, right? Because like that's the first product, right? So if x1 minus 2, this guy is actually this positive 1 first. So x1 is just 3, right? Now we can actually go on to say this x1 minus 2 can be negative 1 now, right? Because you're either taking plus 1 and plus 4, or you're taking negative 1 and negative 4. Okay, so that's like the pair. All right, so this x1 minus 2 must also be negative 1, so it makes x1 to be 1 in that particular case. Now the other pair is actually x2 minus 2 must be 4, right? So this are like our 4 here. So if in that particular case you actually have x2 to be 6, or our x2 minus 2 be negative 4, and that's our negative 4 down here. So in that case we have x2 to be negative 2. So we can go on and then form the other pair with this guy. So we have this x1 minus 2 must be positive 2 here, which gives us x1 to be 4, or our x1 minus 2 be negative 2, which makes our x1 to be 0. Basically do the same thing with x2 minus 2 and then plus 2 and negative 2, and then we have the result like that. Now what you notice is that the 4 possibilities use the following pairs of solutions, right? 0, 0, 1, negative 2. Now how do you know this? Now come here. we've just said that we want to get x1 comma x2, right? So you notice that our x1 here is actually 0, our x2 here is correspondingly 0, right? So you actually have 0 0 here, there. Our x1 here is actually 1, our x2 here is -2, that's why you actually have 1 -2 there. Our x1 here is actually 3, our x2 is 6, that's why you have 3 comma 6. Our x1 here is 4, our x2 is actually 4, that's why you have 4 comma 4. Now we can actually now get a there, because remember the question is asking us to get the values of a such that the zeros of the polynomial are integers. So what are going to be the values of a? Remember that again over here a is basically the sum of those roots, right? So if these are like our various roots, right? So let's just get to sum these ordered pairs, right? So you sum 0 and 0, you actually have 0. You sum 1 and -2, you actually have -1. You sum 3 and 6, you actually have 9. You have sum 4 and 4, you actually have 8. So that is the end of our problem. I actually hope you enjoyed it, and yeah. Notice how mathematics can be really interesting and really lovely. Thank you guys so much for sticking around. If you enjoyed it, make sure you subscribe and share it to your friends so they can also enjoy this mathematical content. We're bringing on lots of other things like what happens to a student when they fall into a black hole, right? So there's a particular radius that we can squash things down to, that those things basically become black holes, like the Earth. So we can actually squash down the radius of the Earth is about 6.38 times 10 to the power 6 meters. So that's the radius of the Earth. So what happens if we squash the Earth down to a radius of about 300 meters? The Earth becomes a black hole. So the gravitational field intensity around the Earth becomes so intense that light itself cannot escape from the surface of the Earth. So in our next video, we are going to be showing you what happens if you as a human being is falling towards a black hole, right? That would be so cool. We'll be using basic physics and mathematical equations to show that. Thank you so much. So guys, if you're wondering, we want to use YouTube to entertain people with the beauty of science, inspire higher dimensions of scientific love, make mathematics and physics so fun to learn, promote creative thinking and scientific reasoning, foster speed, accuracy, and precision in problem solving, unleash the next generation of problem solvers. Thank you for checking out our channel. We hope you stick around, subscribe, and help us reach more people. If you also want to contact us, this is our email right here and our Facebook page. And of course, you can actually reach out to me personally on WhatsApp or through a quick call. Yeah, we hope you keep enjoying and stay curious.